So we have with us today a very special guest, Amit Chatterjee. Amit, welcome to the session and thanks for making time for us. I'll let you do a quick introduction about yourself and your long association with the semiconductor space.
Hey, thank you so much, Partha. Good afternoon, everyone. Pleasure to be part of the communication or the discussion that we are having today. Um, Quick introduction on my side. I am a master's from IIT Kharagpur. I am in the semiconductor industry for the last 24 odd years, mainly in the embedded domain, which means that designing from microcontroller all the way to higher end microprocessor is what I have done in my life. At Intel, I am responsible for the Intel Startup Program, where I'm working with innovative startups to see how we can scale with them, how we can mentor them, and all of that. So that's in a nutshell what I try and do.
Thanks, Amit. And just a quick note to the participants, if you have any questions throughout the session, feel free to message in the chat box and we'll take it up towards the end of the session. So I think Amit, let's first start off with a very basic question. What is a semiconductor and what are the applications, right? We've got a mix of different people here, so just for everyone's background.
No, no, sure, sure. So the analogy that I always put in, or in fact, no, it's not my analogy. I think one of my profs said that. So think about it in this way: if you take a human body, and if you put in the touch sensing, all of the nose that you have, or the eyes that you have, this is essentially what we call as sensors, or these are the analog land or analog world, right? They are now getting converted into electrical pulses, which is what our sensors are doing. They're converting into electrical pulses, transferring them into a high-speed bus, which is nothing but our neural network, or rather, let's say our nervous system, and then going back to the brain. Now, your brain is what is processing all of these data and then trying to figure it out. That's essentially what we call it as a general purpose processor in this particular case, right? Now, general purpose processor, which is what we are working on, is capable of doing certain things. There are certain aspects of the general purpose processing that one person is good at, or the second person will be good at, or third person will be good at. There would be certain aspects that we try and do, and essentially how big the processing engine is or how small the processing engine is, depending upon that, you choose what category of let's say compute you want to use, right? So whether it's a microcontroller class or a microprocessors class or a server class, more or less they are just a combination of how much compute you want or how little do you want. But it's a combination of analog and digital. That's essentially what a system is.
Yeah, thanks for that, Amit. So, delving deeper into the industry, right? So, semiconductor industry is going to be a $1 trillion industry by 2030, right? And with a growth rate of double digit that we can expect. But the industry has also seen its fair share of challenges in the recent past with global chip shortages, increasing demand, with COVID taking a disrupting role throughout the supply chain. But we are also seeing a few positive signs again, right? So with the industry again coming back in its own way. So how do you see the current challenges and of course the future opportunities, and where is the industry heading towards from your experience?
See, one thing is for sure that any and every devices that we have right now will need silicon, whatever silicon. You cannot not have a silicon anymore. That's for sure. Earlier, even earlier days, even your vehicles never had any silicon, or there was no need for it, right? Even just a simple mechanical control was able to take care of it. But now we need electronic braking system, we need electronic steering system. You will not operate a car without all of these capabilities, or the next version of capabilities, which is not possible from a purely mechanical system. So that means more and more silicon will be required. Now tell me if any child, for that matter, who doesn't have access to a cell phone, which is a big silicon in the ecosystem, right? So it is not. So silicon is part and parcel of each and everything that is going to. And when I say silicon, I'm talking about both analog and digital. about only one aspect of digital, right? Somebody has to convert the analog. There is no analog computer here. So there's somebody has to convert that analog, which means there are sensors. There are small sensors, big sensors, whatever we want to call them, and then those are connected to a digital landscape, right? So our intention over here is to be able to give those details out, those integrations out, and then bring things to the table. Now, coming to let's coming to the second portion of your question that you had, I would be able to figure out from a now. Okay, so now manufacturing of these sensors. So the second portion of the question that was there was that, okay, how do I? It is a big market. Yes, everybody needs it. Yes, everything, including your simple washing machine to a complicated robotic surgery device, requires a silicon. Yes, but then who is manufacturing it? Who is integrating it, who is producing it, right? And I'm talking about the product. So there's a big supply chain that is there. Silicon manufacturing is a consolidated market purely because of the initial very heavy cost of investment. The cost of investment requires a huge amount of money spent on the infrastructure, the money that is spent on cleaning the air that goes in, cleaning the water that goes in, getting the right amount of material that comes in, which is nothing but sand. But where is the sand coming from? How clean are your material? Where are you sourcing it from? All of those different things are definitely a consideration. But having said that, that's a consolidated market. Very, very, very consolidated market. You just hear 5 or 6 names in the cutting edge digital landscape. However, when we talk about analog landscape, there are multiple players. Even for that matter, all the IITs for that matter, IIC lab in Bangalore for that matter, capability of developing good quality sensing technology on and making and building it in a really miniature manner. Now the fun part is that it is not the sensor which is that small, but the package itself makes the device need not go lower than 180 nanometer, right? So it's fine. So in some cases, or in quite a few cases where your silicon technology need not be that low, are the cases where I would say a lot of new improvements or now a lot of new techniques that are being built out. But cutting edge is very controlled, very, very, very controlled.
Yeah, interesting. Yeah, and of course, I think even from the industry perspective, there have been, I mean, pushes on, let's say, cost optimizations, finding, alternative materials also. And some people are also looking at, distributed fabrication also as one option. How do you see those developments going in which direction? Of course, you mentioned that this is very consolidated, right? So, keeping that also, that constraint in mind, where are we heading to?
No, yeah, no, thanks, Partha. So yeah, so it's a little tricky scenario. So I'd like the example that I just took about a human body and a human brain. Now think about it in this way: a brain has some basic function of control, motor, and all of that. Those are very standard. So that is what you will analog, like analogous to that, or want to compare it across. You can think about it as a general purpose processor that everybody has in their head. Okay. Now, I come from a techno commercial background, so I understand numbers a little bit. And hence, if you show me an Excel file and show me some data and all of that, I will be able to understand them very quickly. Will be able to do some processing on that or using my brain. Now, let's say you, Partha, may be a great singer, maybe a great musician, right? My wife tells me very categorically, stop singing even after I even start a single line, right? I'm bad at it. Come on, I'm just
Yeah.
accepting it. Now, if you tell me that train, and eventually become a singer, sure, I will be able to become, but maybe I'll need 10 years. While somebody like you, who is trained or who is good in that aspect of work, I'm treating singing as work here, then you will be able to pick that up much faster. So that's essentially what I call it as a accelerator service or accelerator solution, or you can call it as chiplet strategy, right? So what is happening right now is that your main processor, which is a bulk of your processing control functions, security functions, all of those are available in the main block, while your smaller task, very, very defined niche task, right, they can be in a chiplet or an accelerator. A very big example of that accelerator is a GPU, and everybody knows NVIDIA. So I don't have to put in and talk about that. That's essentially the reason why NVIDIA is scaling up, because it was very good in data mining. We realize that, right? And that is one of the reasons why, and even for that matter, Gen AI related activity, which is nothing but a parallel task, and you are able to do parallel computation combination, converging the outcome somewhere down the line, right? So the point is that those activities require smaller but multiple compute elements, right? While in some cases, maybe a financial transaction or financial fraud detection is not a simultaneous task. It's a chain task. It is one transaction to the next transaction to the you're supposed to track the whole chain of transaction and then figure out, okay, is there some anomaly that is coming up, right? So in some cases, a regular standard operation will make sense. So those accelerators are the ones which are creating what we call as a differentiation of for the activity that you are trying to do. And the fun part is you need not be at the bleeding edge for it. You need not be. You can be at 45 for that matter, or 180 for that matter, if you are able to do it, right? But the thought process over here is to be able to get to that custom engine for your work. And you need not have a very, very high consolidation of volume to be able to do that piece of work, right? Now, that's the fun part. That is where most of, I would say, silicon design or silicon designers are working on. And then obviously it makes easier for you to build that small piece, integrate it with a larger piece, and now your system is ready. So that's kind of the work that a lot of people are working on.
Yeah, interesting. When we look at of course, there was this whole supply and demand thing, right? So with the demand driving up for global chipsets, and we saw that there was a need for even increasing supply, right? So that definitely is also increasing production, and with that also comes the whole GHG emissions. So what are the opportunities for decarbonizing that you see in this space? And when I say decarbonizing, of course, there are different scopes, right? So there's scope one, where we talk about the different
Yeah. So
process.
now again, let's break it down into two aspects.
Yeah.
Yeah. Sorry. Is it low bandwidth? Okay. Am I audible here?
Yeah. We can hear you, Amit. So I was saying there are different scopes also here, right? So scope one, we are talking about the process gases. Scope two, we are talking about the utilities and the production. Scope three is more upstream. So of course, I mean, when we look at the emissions, it's mostly in scope one, and also a lot of it is also scope two. So where do you see the opportunities for decarbonization when we look at the different scopes also in the space?
So see, semiconductor industry setting up a new line, setting up a different fabrication line, it's a long process. The reason why there was a huge supply crunch issue that happened was that, see, everything has to be an order pipeline and backfill that happens, right? So automotive industry was a big part of it, or rather is a big part of it. When COVID happened, automotive industry came back and said, sorry, we don't want to commit on a volume, or even for that matter, the OEMs who were supplying devices to the consumers, they all came back and said, no, we can't give you a commitment of an order because we don't know what's going to happen. Fair enough, right? So what happens is that because of that, the supply lines or the supply chains were throttled. Throttle means that why do I run those lines? Why do I even need to manufacture so much? And remember, it's a 24-week time. It takes 24 weeks for you to able to get the sand out, clean it up, build it, cut it in disk, etch it, lithography, then apply lithography, apply on top of it, then apply chemicals, then do the packaging, and then finally churn it out, right? It's a 24-week cycle, 24 to 30-week cycle. Now, when you are looking to do all of that, that means I need somebody has to give me the order. Otherwise, I will not do it. Right? Any silicon provider, whether it is Intel or whether it is somebody else. Now, coming to some aspects. So let's go step by step. When we look at decarbonization in that particular footprint, frankly, and chemical silicon manufacturing industry is highly automated. And it is not because I have to do it, it's a good for me to do. No, it's mandatory for me to do. And because I can't afford to have human skin as pollutant coming inside, right? I cannot have the quality of air, because when I'm flushing everything out, I can't have dirt and dust coming there and ruining the whole process. When I lose a disk, I lose a pretty decent amount of silicon. So for me, automation is paramount. It is not a good to have, it's a must have, right? So everything for that matter is highly automated, highly controlled. The whole supply chain is automated. We have to do it because of the guarantee or the expectation of outcome in a very time bound manner to be available, right? So everything in the silicon industry is very I would say sorted out. And since there are very large players, they have also sorted out where the chemicals are going to come from, where the raw materials are going to come from, where the rare earth metals are going to come from, and all of them are sustainable and or at least sourced uh, with a conscience, right? So you are not going to have conflict material coming in and all of that. So that's an activity that every silicon manufacturer does, right? And there are very few. So that's anyway taken care of. But coming to the second part of it, the big guzzler of energy is actually the usage of that silicon itself. So I take the silicon, I use it somewhere, and then I am trying to, now for me is to be able to optimize that use of silicon so that I can use less power, so that I can use less overall energy. And that's like a big decarbonization activity that we are trying to do. Coming back to our plants itself, yes, absolutely. And I can talk about few of the initiatives that we have tried to do. But there are more activities or more initiatives that are being done on the usage of silicon, and very innovative examples that I can share briefly.
So, since you mentioned some examples, I think you did have a couple of examples that you wanted to share. So I'll let you bring forward a couple of innovations that highlight the use cases.
Oh, absolutely, absolutely. So now coming, okay. So let me just do one thing. Let me see if I can share my screen quickly. Is my screen visible?
Yes, yes.
Okay, perfect. Since I am running the startup program, I have to quick brief introduction
Yeah.
of what the startup program is. So this is essentially what we do. We have a pretty interesting engagement on with the startups. So we have around 75 odd startups that we work with. There are a couple of engagements on the right hand side, which I would like to give you a small brief about on how these differentiations are bringing in value to us. And then obviously after that, there are a couple of examples that I just want to talk about. Now, if I see the first section on the left-hand side, so just to give you the mouse, this is the place. So we very quickly realized that, and again, I'm not talking low in any manner for India-specific discoveries or India-specific developments, but the requirement for semiconductor industry is very tight. Right? Generally, all the development work that is happening is very controlled. So because of that, finding solutions for our requirements are very few, very few, right? That doesn't necessarily mean that we can't help people who are developing different products. So usage of the silicon for something on technology side, well, like for example, machine vision, machine inspection, supply chain automation, running AI or running something else, right? There are a lot of those tech capabilities that we have a quite an in-house expertise on, right? And when I say in-house expertise, I'm talking about principal engineers and senior principal engineers as part of Intel. Now, what are these? These are tech ladder experts. They have been in the industry for 15 plus years. They have patents, papers, and all of those publications. So they are what I call them as vertically focused people. They understand what they are talking about. When we work with the startups, we also give them guidance on what their product market fit would be. So obviously we don't work with early stage startup, we work with mid stage startup where they have been working on some idea. So if they have completed their idea, They have now validated some portions of their idea. Now they want to create what we call it as a product market fit from the start, and then obviously go through some strategic business initiatives and all of that, right? So, and finally, at the end of the day, when their journeys are going on, we tie up with multiple people, where we are trying to see how we can guide them or help them out in fundraising, any credibility that they can bring into the table, any storytelling session that they need to do, any showcases that they can be doing. All of those activities we take care of. Now, on the right hand side, this is where we are trying to do some interesting work, right? So, the first one that we have is from Lightspeed Photonics. This is a startup which was incubated first in India. Unfortunately, they had to register themselves to Singapore also. And they are working on what we call as package to package communication, right? Now, that's a pretty interesting one, or a board to board communication. Now, you have electrical cables, you always have electrical cables. Now, why do I even need a board to board communication? It allows me two things. Number one, it allows me to spread out my designs better. And the second part of it, so when I say spread out, so I can have a one board with a very complicated 8 layer, 14 layer, 820 layer kind of a design, while the second board can be just a 4 layer or a 8 layer design, right? So that way I don't have to extend the same cost of my board to the other section. The big advantage that you also get is the heat dissipation factor. So one board is getting heated quite a lot, and because it is thermally isolated from the other side, you are able to utilize a smaller heat sink or no heat sink on the other side. So automatically the component cost and all of those comes down. So that is something that we are seeing as a big advantage of how the silicon design, not the silicon design, but the platform design or the system design is getting in and creating value to them. On the right hand side bottom that you see Semio, right? This is the company. Now, whenever I am designing some board, some product, I need to ensure that the EMI, EMMC, or EMC is something that is taken care of. Because if it is not going to pass that, then obviously you are going to get a failure, and quite a lot of failures that are going to come in. Now, if I am able to get those design elements and simulation elements earlier, then I can do the rectifications much earlier, much faster, and then failures can be avoided. Right. So I have a quick slide on this particular part. But in a nutshell, what we are talking about is that look, there's a lot of usage of silicon that I'm talking about, and there are a lot of new initiatives that we are trying to be working on in terms of IPs that make sense. But a good portion of those is essentially helping us in reducing the overall or improving the overall efficiency per se. So, Partha, you want to have a question right now, or I'll go to the next slide?
Yeah, you can go on the next slide. I'll ask my questions later.
Okay, perfect. Now, this is an excellent example on how we are talking about having different cooling techniques. So, there is a concept called power utilization efficiency, PUE, which essentially talks about how your data center performances are, right? So, it is essentially nothing but your numerator is the total power consumed by the data center, and the denominator is the total power consumed by your compute units, right? So, for example, what if you have a CPU there or a GPU there, what's the wattage that is there? So let's say your complete data center is taking 10 megawatt, and your compute elements are taking, let's say, somewhere between 6 to 7 megawatt, right? So just divide it out, calculate the ratio, and you will be able to clear that up. Now, why do we need higher? Why is the number higher on the top? Mainly because of the cooling needs, right? And we kind of realize that look, if we are able to, we have to cool the system. That's obviously required, right? You cannot not have the system cool down because of the heat that it is generating. So we want to be able to optimize that cooling really, really well. And right now we are talking about a PUE which is 1.01 or a 1.02, which is being offered, and they are thanks to what we call as a liquid cooling. I will send a video of it sometime later to you guys if you want to have a look, or you can just search for GRC. You can
Sure.
just look at GRC videos and then you can look at that. So what is happening in this particular scenario is that when your the boards are submerged in a liquid. Now, what is this liquid? We call it as an electro-safe liquid. So that means it is what you see in this particular definition. So this is essentially what we call as a biodegradable non-evaporative liquid, which is electrically safe and thermally conductive, right? So they are, if we are able to take the heat out, use that heat for something else, instead of heating it out from, let's say, instead of getting heat out from the air, we are taking the heat out from liquid, right? And that makes the overall system hugely advantageous. So 1.5, 1.6 to 1.01, 1.02, you can imagine the kind of saving or the carbon footprint reduction that is happening in what we call as a liquid cooled system, right? This is an excellent example where decarbonization is happening. A new material is being used. Any questions on this one?
Interesting. So, one question, Sumit. So,
Hmm?
these innovations you also mentioned at the beginning, right? So, this
Hmm?
is a highly consolidated industry. So, what are the opportunities for also startups who are coming up with new ideas, who are at a very early stage? If they have to look at some of the white spaces in the industry, which are those white spaces in your opinion? Of course, you have mentioned a few examples, but beyond that, also, are there similar white spaces that can be explored by new startups looking into or venturing in this space?
No, absolutely, absolutely. So another example of good space is this one, this particular part, right? So this is the part where an early discovery of a EMI, EMC issue or a compliance issue is definitely going to be really helpful, right? Now, this is an example where they are able to define and see whether your system will work, if there are any issues that are going to happen, because you are going to, if there happens later, you have a huge cost impact that is there. So if you want to think about it, Partha, design related aspects are a huge play where there's a lot of work and scope that is happening. So how do I create a new design? How effectively do I turn around that design? Is my design going to be compliant of all the electrical as well as any other faults that are environmental faults that are going to be coming in? Now, India per se is investing hugely on health tech, ed tech, and space tech related equipment, right? So, space tech is the emerging field. There are a lot of space tech related activities that are there. Now, this comes in excessively handy because the kind of emissions that are there in the space, are they more or less? They're significantly high, right? Because thanks to the ozone layer that we have, the Earth we are protected, but the equipment that is going in the space is not. So what do you do to protect it? What type of material do I use to protect it further? There are techniques that you have to apply to be able to ensure that the life of that particular product, because you're not going to send a satellite every 15 minutes or every 15 days or every 1 month. No, that's not possible. So you will have to be expecting the life of the product to be 5 years, 6 years orbiting the Earth and then finally getting destroyed. And when it is getting destroyed, it should not create a debris in such a manner that it becomes a space junk and becomes a huge issue for others. Right? So how do I create those material that after utilization, they get somehow disintegrated and not create issues for others. So those are some of the new techniques or new material that is being worked on. For the health tech part of it, humongous work that is happening on gene therapy, on multiple different initiatives that are happening. Now, all of those require sensors, all of those require equipment to be able to capture from different aspects of, for example, the sensing of human body itself, right? How do I have multiple of these data set coming in without even poking and prodding the human every time? Just a simple drop of blood, can I be able to detect much larger set? Right? I know that the startup that tried to do something like that, we know what happened, but that was then. Now I think that is possible, very much feasible for, and a lot of people are working on that particular piece. So in a nutshell, if there are startups who are working on the design element, silicon design element, silicon validation element, silicon, let's say a product design part of it, not just only the silicon part of it, but the product which utilizes multiple different silicon and bring out a product which is quicker, faster, and you don't have to do too many permutation combinations to make it run. You have to do it, and that's the place where a lot of innovations are happening, and we are actually quite proud that quite a few of them are working with us.
I think that's a that's a very important point, like designing for, let's say, sustainability or decarbonization. But also, taking this a little further, what happens to, what the semiconductors or the materials that are out there already? Are there opportunities for recycling that you see as well? Can there be innovations in that
Absolutely.
space
So
for
this is
materials?
another example that we kind of were evaluating. So this is a group called AMG. They are part of a group called Jumpstart, based out of Hong Kong. We were able to work with them to discover. Now, what they are doing right now is that they are using material. They are reutilizing material. In fact, very recently, I was connected with one startup which is using coir form. Coir, just the standard coir that you get out from the coconut, right?
Right.
Can the coir be used for your conference rooms where you need to have your acoustics settled down? Now, what happens over here? If I am able to, let's say, give or take, reduce my time to a 2.5 dB, or let's say 16 dB is way too much. But let's say if I talk about even a single dB or a 1.5 kind of a dB reduction in the sound that is created, think about it in this way. Let's say I give you a device, simple. Obviously, phones don't have a fan, but you know the laptops have fan. So if I give you a device which is 2 dB quieter, or I increase the performance higher, but I can still keep the same sound of the same sound level, then automatically I'm giving you a boost, right? So that allows me to get a more performing device right to your hand. Uh, that is a big value add over there, and these are all recycled material, right? But using proprietary technology. So that is what are some of the great activities or great things that are being worked on.
Thanks, Amit, for sharing all those very interesting examples. Uh, Coming to the opportunities, specifically for India, uh, because there's a large user base, right, in India for the end users. Can there be solutions that are grown in India? Let's say that's something that starts from a lab, and then we transition it for catering to global client base. Again, keeping in mind that there's a large user base. So keeping and of course there's you did mention the space tech as one example of it. Are there other opportunities that you see, keeping in mind specifically startups, let's say, working from India?
Yeah, no, absolutely. So one of the startups that I would like to call upon over here, morphing machines, right? They are
Hmm.
IIC Bangalore incubated startup. Um, Now, in that particular one, what they are looking to do is the same chiplet strategy, right? So they are trying to work on the latest or the new ways of connecting different compute elements, which are reconfigurable. They are not hardwired to start with. There are techniques that they are applying on how these can be done in a cluster approach. What will happen with this approach is that they will be able to get to specific workloads that they will be able to do perform much better, right? Specifically, like I said, quantum transactions, right? Or others, so financial transactions, not just quantum transactions, financial transactions, right? Now we are talking about quantum safe computing or quantum safe security element, right? We know that our banking system is using 256-bit AES encryption and SHA keys. Now, 256 is also very standard. If you give a 256 key to a quantum computer, it can break it quite easily. Now, if I want to be able to go to a quantum, that means I need to go to 384 or 512. Now, who's going to do that? It's a big compute. It's not small in any manner. Can I offload that particular part to a chiplet which is able to give me a quantum safe design? Those are some of the elements that a lot of startups are working in the country as we speak and developing these key IPs, I would call it. Right?
Quick note to the participants. So if you also know of any technologies out there who are working on similar solutions, we'd love to hear from you at Now Venture Studio. So you can also visit our website, which will be up on the So, Amit, just continuing that discussion, also there are some, innovations on AI chipsets. Like how does that compare to the traditional ones in terms of efficiency or when we talk about, let's say, sustainability aspect as well? What are
Sure.
the trends there?
So see, AI is the most misused word right now. Everybody is trending on that. Earlier it was called embedded, then it was called IoT. Now it's called. See, at the end of the day, what is AI? AI is all about data crunching, getting some meaning out of all the data that you have received over a period of time. We do it, yes, we do it, right? If you, for example, I tell you that your monthly spend is that many rupees, and it is over a period of time, you will also figure out that, okay, am I overspending, am I within my limit, all of that. That's also to some extent crunching or historical data analysis that you are doing. Now coming back to the work that is happening, people are going to be doing what we call as like again the same chiplet kind of a thought process, right? You have to figure out, if you're going to throw a standard tool for all the problems, then it's not going to be an efficient way of doing it, right? Can I run a tractor, can I run a big huge tractor on a field which is very small? Yes, I can. But is it going to be efficient? The answer is no, right? When you have a large field, apply a large tractor. When you have a small field, then apply a smaller thing that is going to be catering to that, right? So handheld small tractors, I don't know if you've seen those. They are very prominent in India because our land sizes are small. The land parcel per ownership is small. So obviously getting that kind of a thought process is what you can think about and relate to. So here, if I, for example, talk about creating a solution which is a sensor fusion solution, which allows me to, let's say, detect gestures, detect interfaces, detect some kind of engagement with the user to control music systems, for example, or control voice, or any interaction with my car, or simple media entertainment that is coming out in the car, or your even two-wheelers for that matter. Yeah. So there are a lot of those smaller innovations for which you don't have to throw a very big system to it, right? You don't have to create a very big piece and then throw at it. No, you can create those smaller subsystems, or chiplets, and then create value, which is going to be your value. Remember that it is going to be unique for your system, because you're not using a general purpose system over here, and you need not have everything software controlled here. You can have a software and hardware tight loop system, which is going to create a differentiation for you, and others can't claim it. So those kind of activities is something that a lot of OEMs are trying to drive from the country. Obviously, it's early stages, but there are some green shoots that are already seen. Now, remember, the reason why I took automotive as a case has a double meaning here, or rather, I would say two aspects of it. One is what I call as a non-functional safety related aspect, right? That is where people are playing around, because media control, you fail a little bit here and there, it's okay, fine. My gesture was misrecognized, that's okay. I wanted the volume up, but it did volume low for that, right? But that's okay, that's understandable. But I will not be able to use that for a functional safety element where, oh, my dashboard display suddenly tweaked. I was running at 80 and it suddenly showed 60, or it showed something. That's not acceptable, right? So what happens in those scenarios is that you will use a very standardized system for your functionally safe areas, while for your non-functional safety areas, you will be experimenting a little. Or what will happen after a few experiments, you will standardize it. You will make it really hardened. The IP is hardened. And then you can move that IP into the hardened area, or you can say move it into the other areas, and then accordingly just go ahead and do that. So experiment, innovate, finally migrate those innovations into what is called as a standard tool, and then deploy those standard tools.
Yeah, thanks, Amit. So, coming back to some other, possible. I'm just thinking out loud here. Also looking at some of the other possible areas for innovation. So there are definitely, process gases, right? When we talk about, scope one emissions, are there any alternatives there that can be
No,
explored?
absolutely. There's a
Yeah.
highly corrosive ones, very, very dangerous, excessively controlled. So if there are somebody who is working on those, if they can work on those kind of device, those kind of things, but remember, it's very controlled. So I
Right.
personally don't see a lot of people who are working on those. Again, this is something that my discoveries are, and I can be wrong in that, right? But if there are people who are working on something which has the same capability or similar capability, but are more sustainable and are more easy to dispose of, I spend a lot on disposing these. I can't just dump it onto some open environment and say, okay, environment, deal with it. That doesn't happen in the semiconductor industry. It is a very controlled. That's the reason why I said it's very, very, very controlled. The water. So, for example, Intel India doesn't leave any water out. Everything is consumed within. Right. We
Yeah.
have complete measures that we have brought in. We have our data centers submerged, like I told you about, where we
Hmm.
utilize the least amount of power. We have solar panels. We have green energy. We have CNG to electricity converters called Bloom Energy boxes. I don't know if you have ever heard of them. Bloom Energy is a pretty renowned name where they
Yeah.
don't burn the fuel; they electrically catalyze those fuel. Right now, we also have a methane generation plant from a green waste that comes out, right? Which is the food waste. We do the segregation within ourselves. So we do the food waste segregation. Whatever little that we generate, we also feed it back to the system, and we get electricity out of it, right? So all of those things are something that we have already done, and we are quite proud of it. But having said that, we are a controlled element, so we cannot just do anything that we like. So having said that, if there are people who are working on it, it would be great to discover. Please let us know if there are something that you are working on. It will always be a good evaluation. But like I said, manufacturing, specifically silicon manufacturing in the country, is very, very, very nascent. So will somebody experiment with those new gases in India? Answer is no. Will they experiment with those new gases somewhere outside? The answer is yes, absolutely. There are people who are working on it. Will I be able to connect to those people and then let you work with them? Yeah, sure, why not? But having said that, the opportunity sizes are going to be very small. I'm just making that very
Yeah.
clear. But nevertheless, it's not zero.
So in the Summit, also looking at some of the questions that have come in from the audience, since these are kind of related to the startups that you had mentioned, I'll probably take some time to also discuss that. So one question from Sagana is that what is the traction of GRC in terms of revenues and units deployed?
Maybe difficult to share that. That's a business number, but nevertheless, they are deploying across the globe. They have deployments in Singapore. They have, so any country. It's a country mandate now. It's not no longer a my own mandate. So country is saying, look, you have to show me sustainable solution deployment at your site. So let's say if you're working with a big large name, they will be forced in this particular scenario to deploy green or more efficient solution. And what is more efficient? GRC is an option. Will I be able to capture all the TAM in that one? Answer is no. But a substantial of it is going to come to you. Now, there is also a catch. Remember that. This is like the standard one, right? When EVs came in, I'll take the simple example. When EVs
Yeah.
came in, everyone was apprehensive. It's going to catch fire. There are explosions that are happening. Batteries are exploding and all, right? But thankfully that has come down because now people have realized that, oh, there's something called as thermal runaway. I can control the thermal runaway by adding more sensors to it or have a better charging methodology and all of that protection and everything that is there, right? So nowadays, touch wood, the incidence of such accidents have come down. Is it come to zero? No, but it has come down, right? It's a similar thought process in any of those scenarios. So when I say that I'm going to give you electro safe liquid immersed cooling, everybody is like, short ho gaya to? Right? That's a very standard question. So because you see it in liquid and you are like, okay, will the liquid catch fire? How do I manage and maintain that liquid? Because I know air conditioning system, I've been using air conditioners for the last 10 years, 15 years. I don't know what liquid cool system is. So there's going to be a lot of questions that are going to be there. So yes, it is early adoption. Will it be the one of the efficient methods? Absolutely. Will everybody take it? No, there would still be people who will say, no, no, I'm okay with what I have because my unit size is small. So let me just continue with what is tried and tested. So those kind of things will happen. Um, are they deploying worldwide? Absolutely, they are deploying worldwide. A lot of utility companies are actually utilizing them. I never thought utility companies will use them first, but they are specifically in the transmission line area, right? A lot of where the generations are happening, there is a boatload of data being generated. And remember, it's a very controlled segment. You can't send utility data out of the country. You just cannot, right? So what's your generation, what's your power factor looking like, and all of those critical data set are being managed and controlled in next to the unit itself, and they are in god forsaken places, right? So you can't have a dedicated fiber optic line going out and controlling and all of that, and they need efficient solution. So a lot of those deployments are actually happening there.
Thanks, Amit. Moving on to the next question. This is from Neeraj. Any opportunities in advanced packaging of semiconductors, sensors?
Absolutely, absolutely. The cost of a sensor is mainly because of its package. You can actually go at analog devices for that matter and look for a vibration sensor, a six-axis or a multi-axis vibration sensor, which is at 2 megasamples per second. The cost of the sensor is going to be some dollars, and cost of the package is $250, right? So yes, the answer is a straightforward yes. Packaging technology brings in a huge value, a huge impact. And if there are people who are working on packaging technology which can really bring that cost down, absolutely, absolutely.
Next one. What are the opportunities in supply chain ion semiconductor industries?
Um, it is there, like I said, but you all have to choose your battle, right? So if you are talking about supply chain or a semiconductor industry, what are the things? It's basically nothing but sand to start with, the critical gases, which is what I'm going to be utilizing, and then after that I have the lithography machines. Lithography is controlled, boss. It's very controlled. Can I get the older generation lithography? Answer is yes, you can get it. But do I get the latest, greatest working on, let's say, 2 nanometer, 3 nanometer? You can't lay your hands on. You won't even be able to get access to any of those critical part pieces. So, do I want to operate in that? Maybe not. But will I be able to operate on supply chain specifically for sensing related? That's the reason why I'm re-emphasizing on that. When you start your silicon design, 40% of it is analog, right? Or system design. Let me not say silicon design. When you're talking about a board design, right, or a system design, 40% of it is analog, maybe more than that in some cases. At least in the health tech industry, analog component has a much larger play, while digital is much smaller, right? So work on those particular area, figure out what type of sourcing and the package that you can do, material that you can do. There are different packaging techniques that you can work on, which will improve the overall efficacy of the system, right? And those are something that you can choose your battle, and you will see good returns very quickly, very quickly, right? And that I believe would be something. Choose your battle. That's what I'll call it. It's not that nobody can stop you, but you want revenue at the end of the day. So if you have small project which is going to get you revenue faster, work on it while you can work on the long term project as part of your R&D. That's for sure you can do.
Yeah. Will companies like Intel look at alternatives for processed gases for manufacturing fabrication?
Sure, like I said, yes. If you have to come, you will have to come back to me with data. So you will have to come back to me saying that yes, the new gas that you are talking about has a similar efficacy, is more greener, is more sustainable. I can dispose it off faster, or I have better methods of disposing it. If you come back to me with that kind of a hard data, why not?
Yeah. You did mention, I mean, during the course of the discussion, uh,
Mhm.
automation, right? So automation is, something that's definitely a must-have, right, in this industry.
Yeah,
And
absolutely.
also with the rise of AI, we are seeing a lot more automation happening. Also, I was just recently reading an article about the semiconductor industry needing more skilled manpower as well. So just getting your viewpoint here on where does where do the industry go from here with a mix of qualified manpower and uh, automation as well, both coming together. Do you see a conflict there, or is it something that's also the industry just becoming even bigger as we go along?
See, automation is something that obviously, again, like I said, tried and tested automation, and every plant is automated. Don't get me wrong. Whatever, wherever you go. I'm not going to talk about whether you go to TI plant, whether you go to TSMC plant, Samsung, Intel, Global Foundries, anywhere you go, they are all automated, highly automated. Now, when you are talking about the type of people who are working in those plants, you will have physicists that are going to be, you will be having chemical engineers who will be working on those. You will have what I call as labor forces working on them. So, skilled labor requirement within a plant, specifically from an automation point of view, it's only maintenance. Don't get me wrong. That's essentially what it is, right? It is essentially what we call as maintenance staff, because we want to ensure that everything is running smoothly. Are they the ones who are expert in creating automation solutions? No, they are there to maintain whatever the infrastructure that is there. Now, coming back to the type of people that we require are definitely design engineers, more design engineers, more packaging scientists, more packaging, somebody who can help me out. Like, obviously, some patents are pending, but we are looking at different layers of packaging instead of just having one layer of packaging. Can I have packaged of layer one silicon on top of the other silicon and then stack it up? Because I can't go horizontal anymore. I have way too many things, and if I go horizontal, my size of the package or my size of the solution is too big. But if I go vertical to some aspect, if I stack it up to some aspect, I will be able to create better efficiencies. It's the same thing as an apartment versus houses. How many houses will you build? But you are building more apartments, right? So that's kind of the thought process that a lot of people are working on. And there are some essential patents that a lot of people are filing. But having said that, yes, there are people that we need who are working on these areas, right? And creating solutions that are innovative.
Yeah, thanks, Amit. Moving on to the next question.
Mhm.
Is there a market need for solvent slash water, organic solvents used for chip fabrication, separation in clean rooms and fabs?
Yes, absolutely. It is going to be a sustainability phenomenon. So if your solvent is going to be able to separate better, again, I said hard data. It is, it's a very controlled environment. You cannot say that, yeah, it might work. No, it has to. So if there is some hard data to prove in where you have done lab tests, you have done some field trials, and that actually tells me that yes, these solvents are able to separate out my active element from coming out from the water, then my filtration system becomes that much easier. That my cost of filtration comes down. So yes, absolutely, those are some of the elements that would be useful. And by the way, that's not just only for me. If you're
Mm.
working with chemical industry, right, process industry, they will also be able to use it. Will I be able to offer you that kind of a volume? The answer is no, straightforward no. But will chemical industry, which is working on multiple of these kind of solutions, be able to offer you a much larger volume? The answer is yes. So choose
Yeah,
your battles is what I'll call it.
thanks a lot, Amit. We have gone through all the questions, and thanks everyone for tuning in. Thank you so much, Amit, for sharing your perspectives and insights into the industry. We learned a lot about the trends, challenges, opportunities, and more importantly, what are the white spaces that aspiring entrepreneurs can look at. We invite new ideas, new innovations, or anything that you are working on in this space. Feel free to reach out. Our website's link has been provided, so please do reach out, and we will get in touch with you. Thanks everyone for tuning in, and we'll log off now. Thanks.
Thank you so much.